welcome back to our YouTube channel, Becoming a ROS Developer. I am Desire, and today we have got Yusuf, who has completed the project. Let's just say his project on Linux Basics, and he'll be giving us a presentation, showing us what he did, how he managed to complete the project. So first of all, as usual, we'll see a demonstration on the real robot. So we'll see his code base running on the real robot, and then we'll get into the details about how he's managed to complete his project. So what I will do now is I'll hand over the platform to him so he can begin his presentation. All right, Yusuf, whenever you're ready.
Okay, good afternoon. I am Yusuf Solomon, and I have been another basic robotics course. I also finished the project, and I'm here to present that project, the naive obstacle avoidance robot project.
Mm-hmm.
And here I'm for my project to load. But before that happens, I'll just quickly run through what the project is supposed to do. So, writing a throttle board with laser sensor that the sensor senses the front left and front right. And then using a solution based on proximity between the robot and the front left, front right, and the front, the robot moves based on that to avoid obstacles, to avoid colliding with any obstacle on the way.
Mm-hmm.
So, waiting for the robot to load. That seems to be running for the
Yeah, I think maybe you refresh the whole page so maybe it starts again.
only here. Okay. Okay.
All right.
There it is. Okay.
All right. Can you be explaining what you'll be doing so we can
Yeah.
understand?
So now I'm connecting to the robots with this command, connecting to the robots, and also launching the ROS to see the sensor in it.
Mm-hmm.
You see that. And run the robot interface. Yes, this run the navigating to the directory run for this, and then run that. So get it ready. Now get it ready. Yes, I'm going to run the stock avoidance code.
Okay.
Okay. Yes. Okay. Here it is. Yes. So this is the outputs. These are outputs that I like to show at the terminal.
Mm-hmm.
So here it is printing out the left range of assistant from left range. Here it's printing out front left range,
Mm-hmm.
the front range, right range, all that have sense. And this is saying that it is moving forward.
Okay.
This will start printing now. It's turning right. Yes, as you can see. Yes, and then turn right again, move forward. Turn right again, and open it.
All right. All right. That's much
Yes,
better.
and then now move forward. Yes, yes. Now this is now you should continue moving forward since there are no obstructions.
Mm-hmm.
Yes. Let me this. Yes. Let me show the sensor data. Mhm. This is showing what movement. I don't want to result the time out for the robot
All
because I
right.
still have the Python. So can I get to explain the code?
All right. Yeah. Let's go for it. Um.
Okay, let me do this. First, we're going to see the process
Yeah. It should be fine.
here. Same thing. Yes. Okay. So it's my code. So in the line of robotics course, I learned a lot of things about Linux commands, the Linux command line, and how to navigate the directories, how to run processes in the background, how to assign permissions to particular files,
Mm-hmm.
and how to write bash script. That's one of the most important parts of the course. And it was the using of bash scripts it was the writing of bash scripts that I used for this project. The for the Java project.
Okay.
Okay, so I'm still waiting for the code to run up. I think I have it somewhere. Okay, I think So our
I think you created a new file there. So
oh
yeah, there's an error.
wow, what is the it is open now.
The next one.
Okay,
Yep, that one. Now
still not open.
you can open with Vim. We can see.
Okay, I should open again. Okay,
Yeah, open with Vim so we can see. Tab.
yes, okay, so this is it.
All right.
Okay, so first we have to include this bash, this bash script.
Mhm.
This bash script contains all the robot functions that I will be implementing here,
Mhm.
and then we output, we first of all this initializes that it's a bash script, so it is run as a bash script on Linux.
Okay.
This is outputs to just tell the users what is happening,
Okay.
and then yes, and then this initial are making the robot stop. So these commands here set the robot's linear and angular velocities to 0.
Okay.
That makes the robot stop. So if the robot is moving when we start our program, it first stops the robot.
Okay.
Yes. And then we're setting the threshold. This is a variable, setting the threshold to 0.3 that we'll be using in the code. So now, this is a loop, a while loop. So it is an infinite while loop, so it continues running no matter what
Mhm.
because I put no conditions to stop. So this is a while loop, and then these are all the things that happen. So firstly, it gets the scan, the left range here. This part with the particular function gets scan left range, and then
Mhm.
it assigns it to this variable, and then yeah, it tells the users that yes, that's going to be scanning left hand range, and this is the left hand range meters.
Mhm.
And that does that for four more variables. And then after I have gotten all the languages, now we are I am going to be defining more variables, and these variables are booleans to check whether the front range, the front left range, and the front right range is free.
Okay.
Now to check this, we would check whether the sensed front range
Mhm.
is larger than the threshold value that we have set at 0.3. So if the front range is larger than the threshold value that is 0.3,
Mhm.
then that means the front range is free. Yeah, checks it and then assigns it to this value. Whether
Okay.
it's free 1, whether it is not free 0. And
Okay.
does that for these three. Front left range, front, and front right. Now, now this is the main code that is using um, conditional statements
Mhm.
to check, to alter the flow of the code to check whether or not the which side is free, and based on that information it does some particular action. So
Okay.
this first code, this one is the condition for whether none of this is free. So if the front is not free, the front left is not free, and the front right is not free,
Mhm.
that is what it's saying here. Front free equals to 0. This one will be true, this one will be true, and this one will be true. So when all these three are true, this particular block runs. So
All right.
after the it has checked that, now it checks again whether is the left range is larger than the right range.
Mhm.
So to
So
check
so
which one, so now we turn left. Yes,
if there's anything, if any one of those three is false, then what happens? Does it? If any one of the
if
three
any of these
conditions,
three
yeah,
is
is
false,
false, yes.
this particular block will not run.
Okay. All right. So
It will only run when everything is true
okay. All
because
right.
of the and.
All right. Yeah.
Okay, so that is for that. That's okay. So now we want to turn, since the front is not free and the left and right is not, we want to turn, but we don't know which particular side to turn to yet. So we'll check whether the left, we want to turn to the, rather the left or the right.
Mm-hmm.
So if the left is greater than the right,
Mm-hmm.
then we turn left. That is setting the angular velocity to a positive value. That starts the um, drone to start turning left, and then we are setting the stick value to 1.5 seconds. So we are going to stick for 1.5 seconds. That means we're going to be turning at an angular velocity of
Mm-hmm.
0.31416 for 1.5 seconds. When the 1.5 seconds is over, then the next block starts running. And
Okay.
that sets the angular velocity to zero. So, you want to ask a question?
No, it's fine. I was saying okay.
Okay, okay. Sorry. Okay, yes, so it sets the angular velocity to zero back, and then this else, if this else statement does not run when this one runs. This else block only runs if this if block did not run. So then we end the if block with this p statement, and then this is the next condition. This condition is, so we use elif when we have multiple conditions. We use elif, and then at the one that runs, if none of these multiple conditions run, is the else. So this statement, this elif checks the front free. If the front is free, okay, and the front right is free. If the front is not free, the front right is free and the front left is not free. So the front is not free, but the front right is free and the front left is not free. So that means we are turning right. So to turn right, we set the angular velocity to a negative value. We're
Mm-hmm.
setting it to minus 0.31416, and then we sleep for 5 seconds. So that lets us turn right. And then when the 1.5 seconds is over, the next block runs. And that's to stop the right turning. That sends the velocity to zero. So the next condition, if the front is free, right is not free, and front left is not free. So here we just have to move forward. But we want to move forward at a particular distance. At that particular distance, we want to move forward. We want to ensure that we do not, hit an obstacle when we move forward. So I want to move forward the front range minus the threshold. So if we can sense that there is 5 meters in front of the drone, and that's the only part of the front we are going to move until we hit until we are near an obstacle, we would move 5 minus 0.3. So we move 4.7 meters. And moving 4.7 meters, when we are done with moving 4.7 meters, we will see that now it's only the threshold value that is left in front of the drone. And
Mm-hmm.
because it's less than the threshold, either to check again, so the front is no more free, we either move left or right depending on where it is. So to get the amount of time that we should move to achieve this distance, we calculate the distance first with this front range and the threshold value,
Mm-hmm.
and then we calculate the time to move with distance over speed. So this is the speed we are using, the linear speed we are using 0.1. So we divide the distance, let's say 5 meters, and okay, let's calculate it as 4.7 meters that we're moving. So 4.7 divided by 0.1,
Mm-hmm.
that's the amount of seconds we'll move. So it has to be 47. So we need to move for 47 seconds.
Yeah.
It's 4.7 seconds. So we then because of the minus 1 from that time to time. So 47 seconds now is 46 seconds because of the delay
Mm-hmm.
in complete. And then we set the linear velocity to 0.1. So now it's moving at linear velocity of 0.1, and then we sleep for the amount of time that we have calculated. So
Mm-hmm.
46 seconds. Sleep for 46 seconds, trying at 0.1 meters per second, and then would, when the 46 seconds is over, we have traveled 4.6 seconds. We have traveled 4.6 meters. So that means we have achieved what we wanted to achieve. Now, when that is over, we can set the linear velocity back to zero.
All right. All right.
Stopping the check for other conditions again. So this is another one. This whenever the front is free, move a particular distance. So this one checks this one anywhere we see front is free, no matter the rest of it,
Hmm.
we move forward a particular distance. So that's the logic that I use for this. If the front is free, it moves forward a particular distance. And then when the front is not free, that is when it checks left and the right. And based on which one is, which one has more space, it moves in that direction.
Okay, all right, all right.
Yes. So that's it. That's the end.
All right. Very nice presentation, Yusuf. It shows you do understand what's going on. So, a couple of questions from my end. I would like to ask. Um, you mentioned something about the use of the line with the shebang, right? Hashtag, then exclamation mark. What is the purpose of that line? Can you explain that again?
The exclamation marks.
The shebang line. What is the
Which
purpose
line?
of it? Yeah, at the very top.
Which line?
The line at the very top of your script.
Oh, okay. The line at the top of the screen.
Yes, shebang.
Okay.
Yes.
Yes, that tells Linux that this is a bash script. So it runs it as a bash script. This particular line, yes.
All right. I see. Would it
Tells
change
Linux
if you were using a different executor, for example, Python? Or
yes, yes. If we are using Python, yes, we change. We will now tell Linux that we are using Python instead of a bash script. So it knows that it's a Python script and runs it as such. So when we want to run it we go to the directory that has a particular file,
yeah.
and then we use dot forward slash and then a particular file, and it runs it based on whatever you have specified at the top of the file.
All right. All right. All right. I see. The other thing I wanted to ask is, I do remember that during your course about Linux basics, right? You make use of the kill command. Can you give me some details about when do you use that command and under what conditions most of the time?
So when we want to end the particular process,
Mm-hmm.
that is when we use that command. We use the command when we want to end the process. We don't run the process anymore.
All
So
right.
we use the kill command.
All right. Understood. And can you give me some subtle differences about how that might differ from just Control C, for example, right?
Um, if the command is running in the background,
Mm-hmm.
it can specify the particular process ID and
Yeah,
then kill the command that way. But Control C just is the command that is running, that is forward running on the terminal right now that we can see running.
I see. I see. Okay. The other thing I was looking for is, let's say you does your script, right? Does the running script have an option when you use the Q command? Does it have control over how it terminates its execution or not? That's what I wanted to find out from you.
Yes, yes, we can. Yes, we can either kill it completely or we can push it to the background with kill command.
Okay. All
That's
right. All right. That's good. That's good. I understand that. Well done. I like the answer. The other thing I wanted to ask is, you remember HTOP, right?
H12.
HTOP, HTOP, HTOP.
H-top. Okay, yes, I remember H-top.
Yes. Well,
H-top.
can
I remember
you
H-top.
tell me some details? What is the purpose of that?
So H-top allows us to see all the processes that are running.
Mm-hmm.
It allows us to see what's the RAM that the process is taking, the space that particular process is taking. It just visualizes for us. Not much of a visualization though, but it just tells us what processes are running on Linux on your computer.
Mm-hmm.
That's
Mm-hmm.
what we use H-top to do.
All right. All right. All right. I see. All right. Very nice presentation, Yusuf. I would say for this one, well done. You do show that you do understand. So, if you would kindly run your other Python demo, I think you still have some time, so we can see if it can run on the real robot from the previous session.
Yes, okay. So, okay, let me close this terminal. have to go to the other project for that.
All
That's what
right.
my code is. So
All right. I hope
just
it runs.
tell me,
Let's see.
yes, I hope it goes complete. So, no, so yes, that's me. Next. So the Python basically does the same thing, but it's just that it is run on Python, and I did in the project I also do two particular methods.
Mm-hmm.
One using procedural programming, that's with new classes,
Mm-hmm.
then use object-oriented programming in that one, and then another one using object-oriented programming, where
Mm-hmm.
I use classes to date some functions. And yes. So let me open the terminal. Okay. Get the particular to run to connect. Yes. Yes, I'm running the command to connect to the robot
Mm-hmm.
and to run the algorithms to
Mm-hmm.
visualize the sensor data. Yes, here it is. And then just to quickly check. Yes, okay. So now can navigate to the directory that has code and then just run it with this. Yes. Okay. Yes. So this should run now. Yes. Okay. Yes. Okay. So this is the robot in action.
Okay. All right.
So the algorithm is not very good, but it should work regardless.
Yeah. Let's see how far it
Yes.
gets. That's the most important bit.
Yes. Okay. Doing, doing very, very fine. This is the same.
Have you encountered this
Okay.
before? Okay.
Was a little too much.
Can you try to explain what might be happening there? Why did it not?
I did not turn right.
Yeah, why did it not manage to do
Yes,
exactly what you
yes.
expected?
Hmm. I have to check the code, but if I could guess, it would be that my condition statement is not accurate.
Okay,
Yes,
okay,
probably in my condition statement, I only give so it's only running commands to turn right.
okay.
At every point, it just turns right instead of checking left and right which one is free to turn, just turns right.
All right. So
Hmm.
there was no proper governing to say if
Okay,
I've turned
it is
this way
turning.
or
Excuse me.
there was no governing mechanism to regulate how much it turns. It just turns for as long as it thinks there's an obstacle. Is that right?
Yes, but yes,
I see.
yes, it turns as long as if there's no. I didn't specify how many degrees
Okay, I
or
see.
yes, how many degrees to turn for just sleep for a particular time.
All right, all right. So
Although there was a function for that, but
yeah, but it also that's the whole point of learning, right? It highlights some of the things you could have done better. So it's fine. It's
yes,
important that we managed to do this, and you did see where it gets into uncertain situations like that one, for example, right?
yes.
Yeah, but yeah, it's all right. I think you can kill the process now. It's okay.
Okay.
All right, so I'll wrap it up here, and then you just hang on. We'll finish our conversation on Zoom, all right? All right. All right, everyone. So this was Yusuf's presentation, Linux Basics, and we also managed to see part of his Python presentation that didn't go so well on his previous appearance. So I'm glad we managed to see his Python code base running on the real robot, and most importantly, the one for the Linux Basics, which was what this presentation was for. So until next time, we encourage you to keep pushing your ROS learning. And if you do want to give some of the courses we offer certification on a try, we highly encourage you to do so, as this will enhance your learning. So, bye bye.